Okay, so this is about me. Here's a little pictorial biography, and the thing that's most relevant to this particular presentation is that right now I am in the middle of studying a master's degree in safety science at Lund University, and that's sort of the inspiration for most of this talk. So this picture up here on the left, this is 3 Mile Island, which I think probably most of you will have heard of. Very big, well-publicized nuclear near disaster. And then on the right here, we have the front cover of the Columbia Space Shuttle Accident Investigation Board report. So what has this got to do with making our automation a better team player? Well, I will tell you. So both of these events and a constellation of events around them had very, very big impacts on the fields of safety science and human factors, which in turn has had impacts on what we do. There's a lot of ideas have percolated into our field from safety science and human factors. So 3 Mile Island, there was this huge surge of research into human factors. Operator confusion was seen as playing a very big role. What people knew, what they understood about the situation, the decisions they made were seen as being absolutely pivotal and absolutely sort of the main interesting mechanism of the incident. And so what happened was that all the safety science researchers said, we must study how humans interact with these systems and how they think about things and how they understand and how they know. And the design of this control room was clearly a huge part of it. So in the 80s and in the 90s, safety science wanted to be in the nuclear control room. And it also wanted to be in the aircraft cockpit as well, because aviation and automation coming in aviation, autopilots, autothrottles, that was also playing a major role in changing aviation, and there were a number of accidents and a reaction to that. So we got this field, cognitive systems engineering, and it aimed to just fix these problems. But then, 90s, early noughties, we had some really different disasters. We had things happen like, most prominently, the 2 shuttle disasters, Challenger and Columbia. And that took safety science in this really different direction. People said, wow, okay, these big accidents that we're having now, these are no longer to do with the direct interaction of kind of people and machines. These accidents are to do with organizations. And how do our organizations think about risk, and how do we manage the decisions that we make, what we say is okay, what's not okay? How do we stop ourselves from sort of getting, like the boiling a frog, effectively this normalization of deviance idea? How do we make sure that we don't fall into this trap? And so from that, a field called resilience engineering was born. And this comes from the likes of David Woods, very prominent, Nancy Levison, who spoke at this conference in 2019, just before the pandemic, and people like that. And they really drove this field forward. Eric Holnagel was huge as well. And it sort of moved away from this interest in the interaction with machinery and the way people think, the way operators think. And so because we weren't really around at that time as a field, we missed out. We missed out on what safety science was thinking about in the 80s. And we've never really caught up, I don't think. So we must go back to the 80s. We do. We need to go back and we need to do our homework and catch up on this. So I just want to get us all into the mood for the 1980s. Here we are in Ireland. In Ireland in 1980, we had no money, but we had very big hair. Like a lot of very big hair. And this is right here where we are. In the 1980s, this is what the docklands looked like. We didn't have a big shiny convention center. We had semi-derelict warehouses. So just pretend you have big hair, no money, and you're sitting in a derelict warehouse, and we will get right on to the good content. So this is a conference that is about operating distributed systems software. By the way, for young people, this is 1983 War Games, Matthew Broderick. So these days, we run our software using lots more software, and that fundamentally is what this conference is about. We're using our software to control quite complex dynamic processes like normal operations, rollouts, migrations, backups, failovers, et cetera, et cetera. And we use it when things go wrong. And sometimes it contributes to things going wrong, and sometimes it helps us fix it. But we are basically collaborating with these systems that we build. It's not that that's a system and you're something else. You're a part of that system, and it's part of the same system that you are, right? And you and your systems together are knowing and understanding and planning and deciding and problem solving and analyzing and synthesizing information and assessing and judging, and it's all integrated. So, cognitive work. This is what you do most of the day, most of you. You're thinking about things and you're trying to make sense of the world and decide what is a good thing to do in the world and what isn't. And does our software support us in doing this? So much of the content in this talk is sort of a distillation of a deep dive I did into these two books, which are about joint cognitive systems by Eric Hollnagel and David Woods in different author order for some reason. But what I've tried to do is sort of relate the content here, to the work that we do. You know, how do these ideas map into our domain? And I encourage people to read these books, they're great. But the big idea is that when you take computers and you start automating some part of your work, you don't just take one slice of it and sort of say, okay, this is the computer now. You know, this is not relevant to the rest of the world. You don't slice your pie up. You still have one pie. It's not a pie, it's like an ice cream sundae. You can't slice it up into slices. It's messy, it's gooey, right? So, you know, when we automate work, we change the nature of the whole system, and sometimes we don't see the impacts of that for years. So I've seen quite a lot of anxiety developing in our industry in the last few years about, young people coming up these days, they don't know Linux and they don't know TCP/IP, and they just use the cloud. And that's actually partly like a downstream second-order effect of the way that we run most of our systems now. People are coming up learning cloud, and that means that we live in a slightly different world in terms of people's skill sets and knowledge. That's just one example. So this idea of maba means men are better at, machines are better at. And there's actually this really sort of quite vicious academic debate about this, because on the one side you have these quite traditional people who are like, yes, people are better at this stuff and machines are better at this stuff, so we carve up the work and it's great. And on the other side you have the joint cognitive systems people who are saying, well, no, there's still just one work and actually everyone is part of the same system collaborating on it. So, it's a very, very spirited academic debate. But people are still debating this, and people are still, a lot of people still have the old maba view, which is largely discredited. Like I say, there's a debate, but, So we see things like this. This is Trey Stevens from Onduril. He says, the key thing of what you're enabling is that you're enabling people to do what people are good at, and you're enabling machines to do what machines are good at. That's an absolute distillation of the maba view. And by the way, I used Onduril as an example only because I'm very sure I never want to work for Onduril. So I can say pretty much what I like about how wrong they are. And there's lots of examples from our industry as well, particularly as people have developed such a big interest in AI ops. So I think we're at a point where interesting times are going to be happening in the next couple of years. And I just threw this in for fun because I never want to work for Elon Musk either. Yeah. So, many of you will also remember this, another 1980s thing, the ironies of automation. So, how many people in this room have read the Lisanne Bainbridge's Ironies of Automation paper? Oh man, not as many people as previous SREcons. Interesting. See, this is how a group of practitioners evolves, right? You can't assume common knowledge anymore. Fabulous paper, really short, still as relevant today as the day it was written. This is the researcher Lisanne Bainbridge thinking about how it is that systems change when you start to automate work. And the big theme of this paper is it's very resonant with the joint cognitive system stuff I was just talking about there. When you automate some parts of a process, it affects the whole. And it increases the demands on the operator. So if you have a system under management, and now you add some automation around it, great, okay, you don't have so much toil anymore. That's good. But now you need to understand not only the underlying system, but also the automation. So there is a bigger demand on operators. And you're sort of left, there's this idea that operators are left with the leftovers, which is the hard, weird work as well. But we cannot operate big distributed systems by hand. It is not feasible. It's not economic. It would be really boring. That would be terrible. We can't do it. So we need to, there's a lot of engineering trade-offs here that we have to make, and we have to do a good job at it. So here, I was writing this talk, and I originally kind of put automation in the title, but then when I was writing the talk, I had more ideas. So obviously, monitoring and alerting, that's very much part of how people understand the world, make decisions, yada, yada. CI/CD systems, config management, orchestration, consoles. So, I've been part of so many incidents where, people need to understand something, so they pop up K9S, or they pop up the console webpage, things like that. Runbooks. Your documentation is part of your joint cognitive system. You write a document today, that will affect what people think and do maybe 4 or 5 years down the line, potentially. So yeah. In short, joint cognitive systems everywhere. This is what we do. This is our jam. But are we doing a good job? Okay. So I wrote these slides about 5, 6 weeks ago, and at the time, this was in the technology news. This person, unfortunately, accidentally their entire website irrecoverably with Argo CD. And I don't want to pick on Argo CD. CI/CD and configuration management tools are very hard. They, of necessity, change state in dangerous ways, and there are horrible trade-offs to be made about, do I want to introduce, it's mostly about, how do I gracefully delete resources in a safe manner, and there's actually no really good answer about how do I do this safely, but also make sure that in my test environments, things aren't left lying around costing me money, or at least there's no great solutions that we've hit on yet. But I think this is still a failure on our behalf, and yeah. Just with Argo CD alone, there's another big outage that Skyscanner had. They accidentally their system as well, and they're significantly bigger and more sophisticated than this sole operator. And I think there's a couple of similar talks at this conference about how people have accidentally themselves using CI/CD. So we're not doing necessarily a great job at this, and I think we need to do better as an industry. So what lessons did I learn when I went and did my deep dive into the Joint Cognitive Systems book? Okay, so lesson 1 is Shocked Pikachu, and lesson 2 is Clippy. And basically this is a rest for me from writing academic papers. I'm like, okay, what ideas can I use to represent these? So what I mean by Shocked Pikachu is automation surprise. We want to build our systems and our automation to not surprise people in a bad way. Because then things happen that we don't intend and don't understand and confuse us, and generally a bad day at the office. But the second one, and this is I think where a lot of the AI ops stuff comes in, is we oversimplify, we hide a lot of things, and we make really strong recommendations to people that maybe are not always warranted, right? And this is the Clippy for production aspect of my concerns. Because one of the big findings of joint cognitive systems is if I say to you, well, when X happens, the cause is Y, and you read that in a run book, or an alert tells you, or some AI ops remediation tool tells you, definitely Y, and you go off and you'll proceed for a while on the basis that it's probably Y. The tools told me so. The tools are never wrong. And it will be very hard for you to break out of the mindset that it must be Y, even if it's not. So it can make our lives quite a bit harder. So automation surprise is the first big theme. This is studied a lot in aviation. Like I said, aviation was a very big player in all this. And there's more human factors research in that context than almost anything else, I think. Basically, automation surprise is when you're running a system and it says, why did it do that? Has anyone ever had a why did it do that moment? I have. Yeah, most of you. Yeah. So this is a problem in our industry. Like, why does it do that? There are 2 big causes of automation surprise. So one is basically you've got some sort of autonomous, continuously running or triggered process that does something that we didn't intend. So Like maybe you push some code that has a bug in a reported metric, and then suddenly your service gets auto-scaled into the ground. So another example is a human triggers something. Like I meant to do this operation, like delete this cluster or whatever, and then I accidentally deleted much more than I intended to because I didn't understand what the tool was going to do exactly. I have seen many instances of both of these kinds of automation surprise in my career. So one of the solutions that I see is a lot of us, systems, they sort of grow up over time, and you're a small scrappy company and you just need a thing to work, and you put in a cron job, and then 5 years later you're a much bigger company with many more systems, and now you have this cron job or something running on system D periodically doing a thing, and you've got some kind of Kubernetes stuff over here, and now you have some sort of continuously running scripts and hooks, and everything is just scattered. It's hard to get a handle on your automation. So I think that's something that we, as an industry, more so than more of the sort of more safety-critical industries tend to do. We scatter our logic around the place, and it's very hard to see what it's doing, to understand what's going on. So one of my principles is I think that out of sight and out of mind is bad. Run things as a full-fledged service if you can, rather than a cron job. Have status pages, have alerting. And a status page should tell you what the tool is doing. What did it do recently? What's it going to do next? Did it have some errors? Give insight into what's going on. The other thing as well is, everyone loves to build complicated things, and I love to build complicated things, as my colleagues will definitely tell you. So this is me being a massive hypocrite, but we should always try and be simple as possible. And in particular, there's a real trap around building tools that have different modes. So like on a Monday, it does this, but on a Wednesday within a full moon, it does that. Or if the system is in this state, it works this way, but if the system is in this other state, it does something different. Very hard. Human brains do not work very well with predicting software and modes. We're not good at knowing what mode we're in and sort of understanding that the system will do different things. It's just not great for us cognitively. So if you can avoid having modes, that's really good. Leading cause of automation surprise. Unattended upgrades. This is something that causes surprise because, again, it's part of this scattered processing theme. It's often kind of turned on by default. There's no central coordination or visibility. It just happens. It's silent but deadly. And I'm going to cite here Laura Devizine and Laurent Benay is probably in the room. Yeah. Round of applause to them for their fantastic talk the other day. Sorry, if I'm going to cite you from stage, I'm going to get you a round of applause. This is a great way to have some automation surprise. So, I think we should try and move on from building tools this way. I mean, if for tiny low, and again we get into this mess because we're building some tools that are great for sort of small, low consequence sites, and then we start running them in as part of our big global deployments, and the two use cases are not really the same. So, clearly displaying intended actions. This is part of what I say when have a standalone, fully fledged service that's got a big status page that tells you what it's going to do. Full details of the execution steps. You should be able to drill right in, see literally what it's going to do, what commands, or what action it's going to do. Estimating resource usage is nice if it's something that takes up quota or kind of API calls, that sort of thing. And any relevant context. An operator should always be able to suspend, cancel, or immediately tell it to do the thing now instead of in 5 minutes. Because this is how, this is one of the big challenges between humans and software as a team. Software is hard to interact with. It's hard to tell it. It's generally harder to interrogate software and to get it to do something that it is to do with another person. The interface is not as good. So, making that better is a huge thing. So Terraform, the tool that most of us know and some of us love. It's actually pretty good. It's pretty good. It's not perfect, but it's pretty good. So it gives us a pretty clear output of what's going to happen. You're going to destroy one version of a thing and create another one. But I mean, it can still cause confusion. Like I have a friend who I swear wasn't me, who had been at Google for a long time, so using the internal Google services for orchestration, which work in a particular way, and then came out in the world and needed to do a big Terraform change of resizing a bunch of instances. And at Google, if you tried to do this on Borg, it would take down one, and it would bring up one, and it would take down the next one, and bring it up again. Terraform doesn't normally do that. So yeah, surprise. So this is good, but it could be better. Terraform could be better if it was more clear about the sequence of sub-operations. And the other thing as well is it's very easy in a Terraform world to build yourself a sequence of Terraform operations that plan perfectly, but you don't have quota to do all the actions that you want to take. So the tooling could be more aware of quota if we put the investment into it. Another thing that happens with Terraform, and again, Terraform is quite a good tool as these things go. I mean, cube operators, say no more. This is from a postmortem that Rafael Elvira wrote, and he, I think, is still in the room also. Rafa, are you here? No? Rafa gone home, okay. But Terraform swallows warnings that the AWS console would give you. So there's no sort of mechanism for the tool to warn you that, oh, okay, well, what you're trying to do is valid, and I can do it for you, but is it maybe a good idea? So here's another example of an automation surprise. So this was from Grafana Labs. They wrote this really great production outage postmortem, and the link will be in my slides when I publish those. And they were rolling out a new way of managing their Kubernetes pods. They were putting priorities on their pods. So the fleet of existing pods didn't have priorities, and they were adding priorities as they rolled new pods out, which is a perfectly reasonable, insane thing to do. And then they decided to roll out a new big service that had a lot of pods. And Kube said, great, oh, okay, these are high priority. These have a priority attached, so they're higher priority than these default priority pods that already exist. So it took down most of what they were running already. And again, you know, you could have a dry run tool that could tell you that that was going to happen when you bring up the new cluster. So it's complex. Maybe it wouldn't be perfect, but we could do better here, I think. But that's all I have to say about automation surprise. We're going to move on to building Clippy for software operations. I think Clippy got taken out of Microsoft Word a few years ago. Do I need to explain what Clippy is? Who knows? Anyone doesn't know what Clippy is? Okay. Yeah. Clippy is, I would suggest that, hey, I see you're trying to write a letter. Do you want to letter format your document? And a lot of us are saying, oh man, our job is hard. Let's, whoop. Also holding a microphone pack is hard. So our job is hard. Our job is hard. Let's automate more of our jobs, and we'll, build like a Clippy, so, like a helpful assistant that will pop up and tell us what to do. It'll be great. I would love if we could build a perfect assistant that would tell us what to do. But the dark side of this, like I said before, is we make really strong recommendations sometimes in our tools. And when we start making really strong recommendations or really strong suggestions, we go down this rabbit hole of fixating on that hypothesis until it's really, really disproven. And that can take sometimes hours in a complex incident with everything on fire. Someone says, oh, it must be X, and you can fixate on X. So we should be very, very careful with suggestions and recommendations. The AIOps hype cycle is here. They can be useful, but they can also be wrong. And like I said before, this does apply to lower tech systems like runbooks. So I think it's much better to say, in the past, this alert has been caused by this. That's subtly different to saying, this alert is caused by this. It's much more definitive. Like, express some doubt. It actually helps. Another way that this pops up is, how many incidents have people in where someone says, it's the network, like it's lots of network errors. And was it the network? Not always. Did you waste some hours debugging that? Or waiting for the network to be fixed? Yes, you did. So yeah, avoid saying it's probably the network. This is a little quote from the Stellar report, if people haven't read that. It's a really fun read. This is cognitive scientists taking an interest in how do we deal with gnarly, horrible software incidents. And so The quote is this: participants formed, tested, and abandoned multiple hypotheses during their exploration of the anomaly in search for the sources. Work was fast and efficient, quick to seek and use information, especially in the early stages of the response where you don't know nothing. But the earliest activities did not appear to be hypothesis-driven, so people weren't saying, it must be this, I will go and look for evidence. They were just scanning through everything, sweeping looks across the environment for cues. So logs are still very useful, because things go wrong. Your logs will generally, many times, give you some clues. SSHing into a VM or an instance can still be very useful, because you can laser in and say, okay, well, I can see it's doing this, right? You can kick around, you can look for these cues. And consoles that show internal states of tools can be really useful as well. But having a system pop up that says, I have to catch it, there's an anomaly over here, could be quite misleading, because anomalies happen all the time. I mean, those systems are very, very noisy, and I really worry that we mislead people about the root causes, or I know I said a bad word, I said root cause. We mislead people about the chain of causation of things if we are very definitive about these tools. So you can pop up, a console that says, or a listing of, here's interesting anomalies that seem to be happening right now, but that's quite different from saying, yep, this happened and it's definitely this. So, who was at Todd Underwood's talk there yesterday? Yeah, good talk, but I have a disagreement with Todd. Me having a disagreement with someone? Shocked. So this was part of the Q&A thread. So someone asked whether an LLM is a right way to go about making a GPT-like bot that can tell you about fixing your issues. Would this be a valid use case? And Todd was like, yes, go for it. You have my blessing, child. Runbooks are terrible. But he also, weirdly enough, said, runbooks are terrible and you shouldn't trust them. So I'm not sure why we trust the things that are trained off of them. But here we are. And I said, I worry about that. Are we going to be here in 2 years talking about a horrible incident that happened because someone ran a command that ChatGPT told them to and it made a giant mess? And I say, almost certainly we're going to be talking about that. And so therefore, SREcon23, me or will be Todd. And if assuming that something interesting happens or does not happen, I will see if I can convince Todd to jointly propose a talk for 2025. But I'm going to say that Todd is going to be eating the humble pie. That's my prediction. So, getting on to our last bit of theory section, because we are actually here to do work, not just to insult Todd Underwood. The two types of tool in the joint cognitive systems taxonomy are the amplifier on the left and the prosthesis on the right. Amplifiers serve to enhance human capabilities. So we as people use the tool to do things more effectively, at a bigger scale, more efficiently than we would otherwise do. So I think a decent example, or the best one I can think of at the moment, is something like Ansible or Chef, or those sorts of old school configuration systems. We can configure machines repeatedly, efficiently. They're not really hiding a lot from us, though. You can get right into the code, see what it's doing. You can look at your logs, see what it did. You can jump onto the box and inspect its state. Like you have a lot of ways in to see what's going on and to understand. It's not hiding a lot from you. But prostheses are quite different. Prostheses try to just encapsulate a complete problem domain and say, don't worry your little head, I got it. This is a black box or an opaque box. You can't see the details of what's happening in here. And I think we have a lot of examples of this in our industry. And I think most prominently, anything that's run as a service tends to be this. So it's rather easy sometimes to shoot yourself in the foot with cloud services by running over some limit that exists, but which just isn't sort of advertised to you or disclosed to you in any way. And that's, well, I've been on the receiving end of that, and it was bad. So you can't debug what's going wrong with these things. So you're just at the mercy of the cloud provider. So that's a prosthesis. Here's another great example I found in another fantastic write-up by Cloudflare, who write many fantastic write-ups. They had built a sort of a bells and whistles, everything batteries included Kafka client. And they wanted to make sure that teams would get up and running quickly. And they just sort of they abstracted too much, and they had a bunch of teams that used this tool and got themselves into trouble with it. I think that's a great example of a prosthesis. You know, you've not given people a way in to sort of build the mental model of what's happening and see when there are problems on the horizon. So, generally speaking, this is the advice. Try to build amplifiers and try not to build prostheses, if you can possibly. That means make the innards of your system observable. Provide ways for people to get feedback on what's happening. So if they use your system to take some action, you know, give the feedback of what is the system doing now in response to that. Is it finished yet? What did it do at what time? And it's more work to build a good amplifier, I think, than it is to build a prosthesis. We like to build prostheses for good reasons. You know, if I can hide away all the internals of my system and not make that part of the API, I can change them freely. You know, I can do other things. You know, I can write much simpler documentation. You know, I can get people up and running quickly with, you know, less work. And we love that, particularly when we're building products. We love to get people up and running quickly, but maybe doing it the hard way is better in some instances. So, the key goal here is to try and help people build that useful mental model of the system that the tool is managing for them. Now, this is very hard. You've got to summarize. You can't just be like putting an event out for every single thing that happens. Maybe you need to summarize that there was 1,000 instances of this thing happened, rather than if it's a really frequent operation. You should provide the ability to drill in to what's happening. Like say, logs, traces of commands that are being run. Exact times are good. Oh man, I beat my head against GitHub so much because it will be like, oh yes, this PR was submitted 7 days ago. And I'm like, but I care if it was before or after 12:10 last Monday, and you're not telling me. Expose how things work. Don't keep it secret. Explain, especially where a system is autonomously triggering actions in response to some sort of set of circumstances. Provide an explanation to the user, you know? Tell them why you did that thing, because one day they'll probably care. And where there are constraints and limitations, show what those are. Don't hide them away like a dark secret, because if you hide them away like a dark secret one day your users will trip over them and hurt themselves, and that's bad. So, I did promise one weird trick when working on a joint cognitive system, to take your SREing to the next level. And it's just this, when you're working on something that is a joint cognitive system, which is more or less everything that you do, probably, ask how does this system help the operator to build a good mental model of how it works. I think that's the most important single thing that we can do. We can remember that we're not just building a system to do a piece of work. We're building a system to do a piece of work in a complex socio-technical system that includes you and your team and maybe your users and customers. And you know, you don't want to leave them stuck, not knowing what's going on, being sad. It's bad. We don't want it. So this slide basically summarizes the entire talk. It does. Try and avoid automation, surprise. Dear God, please do not build Clippy for prod. Avoid building prostheses, and try and build amplifiers. And that's basically the talk. This is me. If someone is interested in some lovely tools that we're building for load management, you could talk to us. I can be emailed. I'm on Blue Sky quite recently. I haven't even put a profile picture up yet, which is terrible. And if we don't get time to do all the Q&A, which we might not, I will go back later and answer any questions in the Slack thread. So thank you so much for your time.